Today we're going to solve this integral from NIT's integration bee. So we have the limit of an integral of a sum of whatever this thing is, and the integral is with respect to x. The first thing to notice, or to be aware of, is that we're able to swap around the limit, the integral, and the sum. They're all linear operators, so they can kind of move through each other, if that makes sense. The only consideration you need to have is what other letters get stuck between the other ones. By that I mean we cannot take any n's to the left of the limit, we can't take any x's to the left of the integral, and we can't take any k's to the left of the summation. But what that does allow us to do is swap the integral and the summation around. So that's going to be the first step. So we're going to have the limit, still as n goes to infinity, of the summation from k equals 1 up to n, of the integral from 0 to 1 of this entire thing. We'll expand that bracket at the top as well. So it's k to the power of 4 multiplied by x to the power of 4 divided by n to the power of 5. And that integral is still with respect to x. Next then we're able to perform that integral. So the first part will stay the same. We've still got the limit as n goes to infinity. We've still got the summation from k equals 1 up to n. But performing this integral, we're going to raise x to the power of 5 and divide by a 5. So what we end up with is k to the 4, x to the 5 over 5 lots of n to the 5. And this is going to be evaluated at 1 and 0. When we stick a 1 in, we're going to have 1 to the power of 5, which is just 1. And when we stick a 0 in, we're going to get 0 to the power of 5, which is just 0. So this entire thing evaluates to be k to the 4 over 5n to the 5. So that's the next line, we'll put that in there. So we've got the limit, as n goes to infinity still the same summation from k equals 1 to n. But now all we've got in here is k to the 4 over 5n to the 5. The next thing we want to do then is try and evaluate this summation. And we can see here we're counting in terms of k's. So everything that's not to do with k isn't affected by the summation. So we can effectively factorize that out of the summation. So doing that, we can remove that 1 over 5n to the 5 from this entire part. So we're going to have another limit as n goes to infinity still. But like I say, we can take that 1 over 5n to the 5 out. Then we've got the summation of k up to n of k to the power of 4. So this, in the same way we know the sum of the squares, the sum of the cubes, we also know the sum of the powers of 4. So we can just substitute that part in. So now we've got the limit as n goes to infinity of 1 over 5 to the n multiplied, but like I say, there's known value for the sum of the powers of 4, which is going to be n to the 5 over 5 plus n to the 4 over 2 plus n cubed over 3 minus n over 30. Spot on then. So next we're going to expand this bracket where we've got this big bracket here multiplied by this 1 over 5n to the 5. We'll expand that out. It's still going to be inside the limit, so we've still got the limit as n goes to infinity of now n to the 5 over n to the 5 will cancel. So we've got 1/25 there plus we're going to have 1 over 10 n in that part plus 3 times 5 is 15. So we've got 1 over 15n squared. And I've run a little bit out of space, but the next one will have a subtraction of 1 over 150n to the 4. Still taking the limit of all these bits. And now then, if we start to think about this term by term, whenever we've got a high power of n on the bottom and nothing on the top, as n goes to infinity, these denominators are going to tend to infinity as well. So the entire fraction will tend to 0. So this one, and this one all tend to 0. So all we're left over with is that 1 over 25. So we've got the limit as n tends to infinity of 1 over 25. And the next thing to know is, well, there's no n's here. So as n changes, this number doesn't change at all. So the entire answer at the end is just 1 over 25. And that's the final answer for the entire problem. This horrible looking integral is just 1 over 25. Lovely jubbly.